Hello, friends, and welcome back to my YouTube channel Electrical Hub. Today, we are going to discuss about the losses in the boiler due to the blow down. I'm not telling that the blow down is not important. Blow down is very important, but we should to be aware of the calculation of how much blow down we should give to the boiler and how much of the energy can be saved by the reduction of the blowdown and what we can do to reduce the blowdown percentage. We will discuss about all this in this video because the reduction in the blowdown will reduce the wastage of the heat energy because blowdown is equal to the loss in the heat energy. Means if we can reduce the consumption or the wastage of the heat energy, then we can save a lot of the fuel to produce that heat energy. So let's start. The topics we are going to cover here are why blowdown is important, what are the types of blowdown, what is the benefits of blowdown calculation, losses due to the blowdown, and calculation of how much loss can be saved with the efficient blowdown. First and the foremost, why blowdown is important. So when water is boiled and the steam is generated, the dissolved solids get contaminated in it. So since this is a continuous process of the generation of the steam and heating of the boiler water, so a huge amount of the solids gets contaminated in it, which causes foaming and carryover. So to maintain the concentration level and TDS, blowdown is very important. So there are two types of the blowdown as we have seen in the power plant to maintain the TDS. One is the intermittent blowdown and second is the continuous blowdown. Intermittent blowdown. Intermittent means it is given at certain intervals. So intermittent blowdown is given to reduce the parameters like TDS, conductivity, pH, silica, and phosphate concentration. What happens in this process? In this process, a large diameter pipe is opened for a short interval. For example, it is meant open for the 2 minutes or less than 2 minutes in an 8 hours of shift. During this process, a large feed water pump is also operated to maintain the water level. So the second is the continuous blowdown. We have seen in the power plant that there is always a steam venting out of one of the pipe. That is always a very small diameter pipe. And through that pipe, the steady and the constant dispatch of the small stream of concentrated boiler water occurs. It helps in maintaining the constant TDS and also the steam purity. The steam purity is very important. We will discuss it later. So a certain question come in our mind that with the blowdown we are losing a lot of amount of heat energy. Is it worth to do the blowdown or we can stop the blowdown? Yes, it is worth to do the blowdown because the blowdown with the blowdown we can have a lot of benefits, but it should be have a proper calculation of how much blowdown we should give and how we should also come to know how we can reduce the percentage of the blowdown. What are the benefits of the blowdown? First is lower the pre-treatment cost. Second, less makeup water consumption, reduce maintenance downtime, increase the boiler life, and lower the consumption of the treatment of other chemicals. The one more and the most important benefit is that if you have a better steam quality with a low TDS, it will also protect the blades of the turbine where the steam is going and it will also help in protecting the smaller equipments of the turbine, and it will improve the turbine life. So now let's calculate the blowdown percentage. So blowdown percentage is equals to feed water TDS into percentage of makeup water divided by maximum permissible TDS in the boiler water minus feed water TDS into 100. So here one important thing to note that if the feed water TDS is reduced, the blowdown percentage will get reduced. So the blowdown rate is equals to blowdown percentage into evaporation ratio. So if the blowdown percentage is reduced, the blowdown rate will also reduce. We know that the blowdown is important, but with the blowdown, there are some major losses, and the most important loss is the loss in the heat energy, which we get from the fuel. So it is very important to control the blowdown, and at the same time, it is also very important to maintain the TDS. If the TDS is not maintained properly, and the contamination in the water is not maintained properly, it may damage the boiler, and also the it affects the turbine. Now finally let us move to the calculation of the savings of energy from the blowdown. For example, blowdown percentage in your plant is X%. So the blowdown percentage is equal to feed water TDS into makeup water divided by maximum permissible TDS minus feed water TDS into 100. So if the feed water TDS is reduced, the blowdown percentage will also get reduced. Now let us assume that there is a reduction in the feed water TDS. Thus, the percentage of the blowdown get reduced to Y%. Therefore, the total percentage reduction in the blowdown percentage is X% minus Y%. Total reduction in the blowdown is equals to, that is the percentage. So total reduction in the blowdown is equal to percentage of the reduction into the steam generation. Thus, the heat saving is equal to total reduction in the blowdown multiplied by blowdown water temperature minus feed water temperature. So finally, savings of the fuel is equal to the heat energy. So heat saving by GCV of the fuel into efficiency of the boiler. It will, for example, it is T kg per hour. If calculated in a year, it will be approximately metric ton. So, with the better TDS of the feed water, we can reduce the blowdown percentage, and thus we can save a huge amount of the fuel and also the heat energy. So, my friends, if you have liked the video, please press the like button, share the video, and also subscribe to my YouTube channel. Thank you. Stay safe, stay healthy.